Hi everyone. Hope I am audible to you. Yeah, let's start the session within few minutes. Just wait for a few more minutes, okay, 4 to 5 minutes so that we can start our session. So for the convenience of more audience, so I have shifted the language from Telugu to English. So if anyone has feeling any uncomfortability, so please let me know so that I can explain you better in another mode also. Okay, so now let us start taking problem. So let me start the first problem. Let me write the problem one here. So I will use simple English only, so don't worry about language for Telugu audience. A 100 ohm resistor is directly connected. Resistor is directly connected across a 10 ohm, a 10 volt battery so what is the current passing through it? What is the current through the resistor? Resistor. So this is one question, and how much is the power loss is the another question. So this is A, and let me call this as how much is the power loss. And one more question, also find the energy consumed in 5 seconds. So find energy consumed in 5 seconds. Consumed in 5 seconds. Yeah, so this is a very simple problem, but we need to know the basics of it. So as we know, here we need to recapture or recollect the Ohm's law. So what is Ohm's law? The current passing through any element is directly proportional to the voltage applied across the element. So if the element is a resistor, then it will be I is equal to V by R, where 1 by R is the proportionality constant. We can simply call it as V is equal to IR. So that's all. So this is the first problem. So let me solve A. So what is the current passing through the resistor? Actually, we want to know the current. We know the voltage and we know the resistor. So simply, what is the current? Current I is equal to V by R. So the voltage here is given as a 10 volt and the resistor is 100 ohm. So 10 divided by 100 will give us 0.1 ampere. 0.1 ampere. So this is the solution for the first problem. And coming to the second problem, power loss. Power loss. So we know that power P is equal to voltage into current. I can also call it as voltage is I into R according to Ohm's law, and this is I. So I can directly write it as I square into R. We can also write this as V square by R also according to the availability. For example, if the first question was not asked and it directly asked the power loss, so how we can proceed? We need to take the formula of V square by R because we don't know the current. Okay, so no need to find current again to solve the power. So simply we need to go ahead with V square by R formula. So as we know the current here, so I am taking this formula. So 0.1 square into 100 resistance. So this is 0.1 means 10 to the power of minus 1. So you can call it as 10 to the power of minus 2 on a whole, and this is 10 to the power of plus 2. These things will get cancelled and you will get 1. So this will be 1 watt. Next, the next one is energy consumed. As we know, energy consumed is equal to simply power into time. So it will be equal to I square RT. So which is equal to 1 into time T is given as 5 seconds. So you can see here. So it will be equal to 5 watt second or 5 joule. You can call it as 5 joule or 5 watt second. Simply. So this is the solution for the first problem. Yeah, I found okay, this part is not visible. C part. So let me write C part here. So energy E is equal to P into T. So that will be equal to I square R into T, and that will be equal to 1 into 5, which is equal to 5 joule or 5 watt second. So both the units are same. So this is the first problem. So let me go ahead with the second problem. So please, you can ask me if you have any doubts. You can simply type in the chat box so that I can able to solve your problems. As this is a live session, so we have that provision. Yeah, let me start solving the second problem. The strength of current in 1 Henry inductor, the strength of current in 1 Henry inductor changes at a rate of 1 ampere per second. So find the voltage across it. Voltage across it. And determine the magnitude of energy stored in the inductor. Determine magnitude of energy stored in it. Energy stored in it after 2 seconds. Okay, after 2 seconds. So let me solve this problem. Yes, so we know that. So according to Ohm's law only, voltage across inductor is L di by dt. This is the formula. So which is equal to di by dt is the rate of change of current. So this is di by dt. This is 1 ampere per second. So inductor value is 1. So simply I can write 1 into 1 is equal to 1 volt. Similarly, energy stored in the inductor is half Li square, which is equal to half into inductance value is 1 and yeah, inductance value is 1 and I square value is, see, this is the rate of change 1 ampere per second. So for 2 seconds, after 2 seconds So my current is changing from 1 ampere per 1 second. So for 2 seconds its value is 2. So here current I will be 2. So 2 square. So that will be equal to, if we get cancel these two, I will get 2. 2 joule is the answer. So that's all. So these are the simple answers A and B. But now I like to incorporate somewhat more information here. So this is voltage across inductor. I want to show the counterpart of it. So voltage across capacitance is 1 by C integral di by integral I dt. Of course, another formula is I is equal to C dV by dt. So this part will be maybe asked in for capacitance. This part may be asked, maybe change in voltage per time may be given. Of course, rate of change of voltage may be given, and you may be asked to find out the current. Similarly, energy stored in inductor is also W is equal to half C V square. Please remember these two formulae also. That's all. With these problems, with these formulae, we can simply solve these sort of problems. Yeah. So the next problem is same type of problem. So I can skip it. So I can simply read this. You just listen to me. A capacitor has a capacitance of 5 microfarad. Calculate the stored energy in it if a DC voltage of 100 volt is applied across it. So obviously capacitance has been given and voltage has been given. So simply you can find the energy stored in it, that is W. So very simple problem. Of course, I think you may know these things. Milli means 10 to the power of minus 3 and micro means 10 to the power of minus 6. So let's move on to the next problem. Hello Girish, good evening. Yes. Yeah, this is very interesting problem. Here we need to identify the element also. So let me do this. Third problem. The current and voltage profile of an element versus time has been shown in the figure. Determine the element and find its value. So very nice question. So let's see this. current and voltage. Profile of an element versus time have been given. So what is my aim? My aim is to find out, determine the element and find its value. So I need to find the element and I need to find the value. So what I need to do, I need to draw the figure first. So these are the figures he has given. So this one is current I, it's rising like this up to certain value. So this is 1 ampere. This one is 5 seconds, sorry, 5 milliseconds. So this is in time and this is in current. Current in ampere. So time in millisecond. And this is the voltage. Voltage applied is 2 ampere. Sorry, 2 volt. So this is voltage in volt. So this is time in second, millisecond only. So this is up to 5. So what exactly happens? So I have an element here. I have an element here. This is my element, and I have given some voltage. This is the voltage and this is the current. This is my element. Let me name it as E. So according to Ohm's law, I should be directly proportional to voltage if it is a linear element. Okay, of course it is a linear element, so it is gradually increasing. So now our job is to find the element. So please think of, so what may be the element? We have learned 3 elements only. So the first element is a resistor, inductor and capacitor. So either it may be resistor or inductor or capacitor. So what may be the element? So we can simply go ahead with the formula. Let me make it simpler. So let me go ahead with formula only. So V is equal to IR is the formula if the element is a resistor, and next V is equal to 1 by C integral I dt is the formula if the element is capacitor, and V is equal to L di by dt is the formula for inductor. So let me make capacitor formula one more formula. I is equal to C dV by dt. If you can see this part, R is simply one value, so that voltage and current should be proportional to each other. That means if voltage increases, even current should increase. If current increases, voltage increases, and vice versa. But here, if you can see, the voltage is keep on constant from 0 to 5 millisecond, but current is keep on increasing. So it is not a resistor. First, we need to remove this part. This is not a resistor. First point. Coming to capacitor, so you can see dV by dt, change rate of change in voltage. So the rate of change in voltage from 0 to 5 ampere, 5 millisecond is 2 only. At 0 its value is 2, and at 5 also its value is 2. So it is from 0 to 5 millisecond, its value is 2. It's a constant. So rate of change of voltage is 0. So it equal to 0. So I equal to 0. That means if this element may be a capacitor, then the current should be 0. So it is also correct, not correct. So capacitor, this will not be a capacitor. So definitely it should be this one, V is equal to LdA by dt. Okay, rate of change of current is, there is a change in current here. From this diagram you can say there is a change in current from 0 to 5. Similarly, the voltage is like this. Okay, so this is the concept. So let us see what is the rate of change in current. So this is, first we need to find the rate of change of current. So we can confirm that the element is inductor because of these explanations. So what is the value? Let me write di by dt is equal to, according to this, it is V by L. Okay, but we can say from these 2 points we can say that it's the slope actually. So I can simply say slope of this line. So how can we go ahead? This point is 0 comma 0 as we know, and this point is on x-axis it is 10 millisecond, comma on y-axis it is 1. So we can simply go ahead with this y minus, so what is the slope? Y2 minus y1 by x2 minus x1. So 1 minus 0 by 5 milli minus 0, so which is equal to 1 by 5 milli, which is equal to 1000 divided by 5 is equal to 200. So 200 ampere per second. That's all. And initial, even here initial value of V is 2 volt. So now we can say that inductor value L is equal to V by di by dt. So V is the voltage value, so that is 2 divided by di by dt value is 200, so which is equal to 10 to the power of minus 2 or 10 millihenry. So this is the value. This is the way we need to go ahead with formula. Okay, even we can go ahead with the theory also. Okay, that can also be learned, but that is somewhat typical, but still we can learn that part also. So I want to tell you that part also. A resistor is the property of the element which opposes the flow of electrons. Similarly, inductance. What is meant by inductance? So it's the property of a material by virtue of which it opposes any change of magnitude or direction of electric current. So it opposes any change of magnitude and direction of current. It opposes. Similarly, capacitor. So it opposes any change in voltage. Yeah, it opposes any change in voltage. So C dV by dt, I mean dV by dt should not be 0. So if you can see here, this is current value, and after at 5 millisecond the voltage is suddenly dropping. As the voltage is suddenly dropping, this element should not be a capacitor. Simple concept. And as voltage and current are not proportional, that means one voltage is constant here and current is increasing, so they are not proportional, so the element should not be a resistor. So the only one chance is the element should be an inductor, because it satisfies this condition. Okay, so it's very simple concept. So you can identify this part very simply. So let's move on to the next problem. Excuse me. Excuse me, actually I am setting the screen, so basically some part is not visible, so that's why I am setting the screen, so please bear with me. So now let's move on to the next problem. A 50 microfarad a 50 microfarad capacitor is charged to retain 10 millijoule of energy by a constant charging current of 1 ampere. A 50 microfarad capacitor is charged to retain the 10 millijoule of energy by a constant charging current of 1 ampere. Determine the voltage across the capacitor. Simple concept. So determine the voltage across the capacitor. So it is somewhat I mean, it's not difficult, but still it is somewhat in a different manner it has been shown. Actually voltage has been applied across the capacitor, so that it is charging now, so some charging current is flowing through the capacitor. So capacitor value is C, and the energy is stored in the form of electrical energy, and that energy is W. Obviously this energy is half CV square. Now everything we know capacitor value and we know the energy stored, that's all. Okay, so we can easily know what is the voltage. Simply, so let's go ahead with this. W energy stored W equal to half CV square, which implies V is equal to 2W by C under V, which is equal to square root of 2 times of what is W? W is 10 millijoule, so 10 into 10 to the power of minus 3, and capacitance is 50 microfarad, so 50 into 10 to the power of minus 3, sorry, minus 6. So this is minus 3, this is minus 6, so minus 3 will remain here. Of course 0 and 0 will get cancelled here, and let me multiply with 2 and divide it by 2, so that 2 into 5 will become 10, and this 10 will go off with this minus 2 times, and minus 2 will go up, so which is equal to square root of 4 into 100. I can say that square root of 4 is 2 and square root of 100 is 10, so it will be equal to 20 volt. So this is the simple problem only, so no need to discuss much. So let's quickly move on to the next problem. Actually I want to conduct this session for 1 hour only. Okay, for 1 hour I like to complete one complete topic. Okay, so these are the basics of maybe electrical elements, we can call it as. So let's finish off this session before 8 p.m. also. Okay, we can easily do it. Already 4 problems are over, so maybe hardly we have 2 more problems, so we can easily do that. So let's move on to the next problem. It's okay. This is fifth problem. A capacitor of 100 microfarad. A capacitor of 100 microfarad stores 10 millijoule of energy. Stores 10 millijoule of energy. Obtain the amount of charge stored in it. Simply the question is obtain the energy, obtain the amount of charge stored in it. Obtain the amount of charge stored in it. How much time does it take to build up this charge if the charging current is 0.1 ampere? So we need to find the time required to charge this much to build up this charge if the charging current is 0.1 ampere. To charge if the charging current is 0.1 ampere. So this is the question. So let's solve this. So let's see the data first. The capacitor value has been given 10 microfarad and the energy has been given 10 millijoule, and obtain the charge stored in it. First we need to find the what is meant by charge stored in. Charge stored in it is equal to, so as we know, the current is rate of change of charge, so it can be written as charge q is equal to I into t. So obtain the charge stored in it. So we can say we need to find the charge now. So we have another things also. We know the energy here, so let me go ahead with that. Energy is equal to half CV square. Energy stored is half CV square. So in this I know some elements, so I know energy stored and I know capacitance, so I can find out voltage here. So I can also find one more formula, Q is equal to CV. So now I know capacitance, so after this I can able to find voltage also, so I can simply find out the charge stored in it. So this part will be over. After that, what is the time required for this charging current? So this formula will be utilized for that, and we can simply find. So at this stage we know the charge and we also know the current, so we can simply say find time here. Okay, let's go one by one. First we need to write, first I want to proceed with W is equal to half CV square to find the voltage here, so which is equal to, which implies V is equal to 2W by C under root 2 into, so what's W? W is 10 millijoule, so 10 into 10 to the power of minus 3. So the capacitance is 100 microfarad, so 100 into 10 to the power of minus 6. This is 3 and this is minus 3 times will go, and this will cancel one time, this will go one time. That's all. So it will be equal to root 2 into 10, which implies it will be 10 root 2. This 10 root 2 volt. So now I want to know the charge. Q is equal to C into V. So what is C? C is capacitance, so it will be 100 into 10 to the power of minus 6 into 10 root 2, which is equal to 1, 2, 3, and this will be 3 times, which is equal to root 2 means it is 1.414, and milli, 10 to the power of minus 3 means it's milli, Q, so it is millicoulomb. Yeah, now it is the time to find out time required to charge this much charge if the charging current is 0.1 ampere. So it will be T is equal to Q by I. So what is the charge? It is 1.414 into 10 to the power of minus 3 divided by current is 0.1, so which is equal to, let me simply change this part, this is 1.414 by 0.1, so it will be 0.1 means 1 by 10, so it will go up and it will into 10, It is 14.14 millisecond. Simple. Okay, it's very simple. So let's move on to the next problem. Okay. Yeah, so let's see one more problem. So this is the last problem for today's session. So the figure exhibits the voltage time profile of the source to charge of a capacitor of 50 microfarad. So what is the charging current? So let us see. Figure exhibits voltage time profile of a source to charge a capacitor of microfarad, 50 microfarad. So what is the charging current? Charging current. So this is the profile he has given to us. This is voltage and this is time in millisecond. And this is voltage in volt. This value is 20. It is increasing. This is 10. So this is a straight line. So don't feel that this is the exponential curve. So this is the simple straight line. So now how to find this? So what is formula for current? Charging current I is equal to simply C dV by dt. So we know the capacitance, so we should be in a position to find dV by dt. So this is voltage profile only in terms of time. So obviously we can find the slope of it. So as we know, this point is 0 comma 0 and this point is on x-axis it is 10 millisecond and 20 volt on y-axis. That's all. So I can find out dc dv by dt is equal to v2 minus y2 minus y1 by x2 minus x1. 20 minus 0 is 20 and 10 millisecond minus 0 is 10 milli. 0 0 will get cancelled and it is milli means it is 1 by 10 to the power of minus 3 and if it will go up it will be 10 cube. That's all. You can write it as volt per second. So now what is the charging current? So charging current I is equal to C. The value of C is 50 microfarad. 50 into 10 to the power of minus 6 into dV by dt is 10 cube. 3 times, and this is 1, this is a 1 time, so which is equal to 5 by 100, so 0.05 ampere. Yeah, sorry, it is 2, this is 20, not 1, so it's 2, so it is into 2. Simple, it is into 2, so as it is into 2, which is equal to 0.1 ampere. It's very simple. So to solve these problems, we have used only voltage and current relationships of resistor, inductor and capacitor, and what is the energy stored in inductor and what is the energy stored in capacitor, and what is current in terms of charge. So current I is equal to Q by T and Q is equal to CV. So these are the formulae we have used in this session. So please make a note of these formulae so that those can be utilized to solve this type of problems. And please try to identify the graph and where to where and how we need to find the slope of it and how we need to go ahead with these things. Okay, it's very simple. So according to graph also we can identify dV by dt. Very simple. So in tomorrow's class, let's see series and parallel combination of the resistors. So they are very interesting problems. So we can able to find the solutions of them. So that's all. So I thought of covering 1 hour of time. So it is approximately 5 minutes prior to our stipulated time. So thank you so much. So if you have any more doubts, you can type in the chat box or you can type in the comment box also once the live session was closed. And thank you so much, and we will meet tomorrow the same time and maybe the same place. So thank you so much. I am closing the live session. Thank you.